Good morning. This is my software architecture project for a food ordering application for software architecture 2003. A clear description of the requirements. My client, after having been in the food industry for over 20 years, wishes to create a food ordering system where his customers can choose items from the menu, order it online, and have the items delivered or scheduled for pickup at the food franchise mobile hut. By building this official website, it will add credibility to his business, increase digital presence, customer engagement, and revenue. Upon conducting user research and competitor analysis, it was found that many local cuisine shops lacked a clean, intuitive website or mobile application where customers can order meals from online from the comfort of their devices. Our client's business is known for providing customers with a wide array of local delicacies, such as doubles, aloo pie, sahinas, bacon chalk, pilau, etc. So the software must be maintainable, scalable, robust, fault-tolerant, secure, and protect user data and user integrity. Data integrity. Customer age range from 18 to 70. So the key features of the software. Desired features would be that of performance, security, reliability, usability, and well-distributed components. The software must be able to be decomposed into different processes, tasks, and threads, can properly handle issues of efficiency, synchronization, automaticity, and scheduling, and of course can handle errors, exceptions, faults, and security. The software architecture model chosen would be the client-server microservices architecture model. The justification of the model is that complex software systems seldom adhere to just one software architecture model. Since there will be many services that will mesh together to make this software possible, this model chosen would be able to facilitate just that. The system design structure, we'll start with a use case diagram. Oh my goodness. We start with a use case diagram where the customer can confirm their orders, browse the menu, which includes the shopping cart, and can extend to checkout. The credit at checkout, the other modules include checking your credit balance, billing and payments, and delivery. For the class diagram, payment, customer, admin, delivery, order, menu, and dish. These are the main classes that will be involved in the app. And to facilitate this, we have designed it in a way that would decentralize the design. Each component can manage its own data, and to help isolate errors in case one component faults. True design is never truly top-down. With the aim of this class diagram, we aim to have simplicity, modularity, low coupling, high cohesion, and information handling. We aim to encapsulate the data and have the data be adaptable and traceable. For the component diagram, the lollipop shape represents an implemented interface, and the cup shape represents a required interface. Some components may be in-house or on the market. We will choose convenient on market. The cart is the front end from a front end graphical user is connected to the graphical user interface using, for example, ASP, JSP, or PHP web pages. The cart needs services from other components such as the catalog, inventory, shipping, credit check, and credit check. For the object diagrams, these are the main objects that will be implemented, as we can see as well from the component diagram. For the communication, diagram, we see the customer browses the menu, and from browsing the menu can add or remove items to their shopping cart. The customer can choose to check out, and from the shopping cart provide their banking information onto which they validate their account. Then after validating the account, charges are applied to billing and payments. After billing and payments, the funds are deducted from their bank account and delivery, after which the customer then confirms. For the sequence diagram, we see the actor or the customer browse the menu of products at the shop website or mobile app. They add items to the cart. They begin their checkout from the shop website or the mobile application. Then they send information to the payment gateway. Many banks such as First Citizens Banks, Republic Bank, Royal Bank, they have their own API which they supply to vendors, which can be installed on their website via plugins. These help process the payments, and then after the payment is processed, it displays a confirmation message, and then the delivery information is entered if they choose to deliver instead of pickup at the franchise. And then from the website they provide their delivery information and delivery occurs. For the activity diagram, we see the flow in which the customer experience moves seamlessly from when the customer requests a food item. They browse the menu and they use the website catalog, and after browsing they can choose to request more food items, and after they've fulfilled their requests, they can then check their account balance, and if they have sufficient funds, then yes, they can proceed to checkout, and if not, then a notification is sent, and then they'll have to end, and then the activity is terminated. And on this side, we see the customer begins their order, and simultaneously, while the credit check is being carried out, there's also a check on the inventory in the database. So here first we will see the credit check. If there's insufficient funds, the order is cancelled. However, if there is enough credit, then we can proceed to delivery. And simultaneously, while the inventory is being checked, if the ingredients are out of stock, then the activity is terminated, and if there is indeed ingredients in stock, then the inventory is updated, and then we proceed to delivery. For the package diagram, this is a tab folder that shows all included classes and sub-packages and where they reside. The packages play a similar role as directories by grouping files in a file system, and so it allows the organization of all closely related classes. So it shows a dependency relationship between packages in which a change in one package may result in changes in other packages. So we see like files such as customer constitutes delivery and payment, cart, food items, cart updates, display shopping cart, catalog, package, food item inventory, and catalog update, and also of course show confirmation message. It can help reduce dependency complexity and also shows a clear relationship between the group of classes. For deployment diagram, we chose a hybrid mobile app development, whereby using either the mobile app or the web server, one can connect to the API gateway. So when oh my gosh, let me just pause. So the account services, the inventory service, the delivery service, they all have their individual databases. As information flows, these databases will be updated. These account services, inventory services, all of them would be updated, notified and updated. So the reason for a hybrid mobile app is that native and mobile web solutions applications would be written in web technologies, and through the use of plugins, the application can have full access to the mobile device's features. Instead of the app being shown, it instead would be inside the user's browser and run from a native application and its own embedded browser. For example, iOS uses WK WebView Framework, while Android uses WebView Framework. The code will be embedded into a native application wrapper using a solution like Apache Cordova. This creates a native shell application which will load the web app. And for the deployment diagram, we have a high-level view of the system. The developer, not just from the user's perspective or the customer's perspective, but also from the developer's perspective. As developers, we build and deploy code using, in this case, a continuous integration, continuous deployment server. The server needs to store data to a database through persistent storage. The server and storage is distributed or connected through a network. So this here will be the persistent storage. The server then responds if the user wishes to connect with the server. Then the user communicates and sends a request to the server, after which the server then responds with its own HTML and JavaScript code, which the user would need to load their web pages. So the server can be a backend server, and then a request is made to our API and our server, which responds using JSON. If users make a request at the same time, it might cause a bottleneck, for which we have a load balancer. This load balancer would help forward requests to servers with a minimal amount of traffic. So it makes efficient use of our servers. For scalability, well, in this case, we can either scale vertically, where the server or the computer that we're using, we can add more RAM or resources or memory to it. However, in this case, we would scale horizontally, where we would actually add more computers so that multiple computers can be running our code. So that way we can handle more requests at the same time. And as developers, of course, we would need insight to how our server is running. So we can use logins and metrics that would, which would let us know, if there's a faulty CPU, if there's RAM, if there's something wrong with the RAM, if the storage is full. So of course, not just logging, but also a metric service. And the developer would be alerted of these things using an alerts and push notification system. For the user interface, well, this is an example of the prototype right here. The online food shop, prices, specials. Here we have doubles, bacon shark, pilau, wonderful local cuisine delicacies. For the user interface and user design, and of course where the customer can put their information, we aim to provide a personalized shopping experience. The user interface design plays a crucial role in the success of the e-commerce platform. Customers will be able to navigate easily through the website app and mobile app, finding the product they're looking for and make a purchase with ease. For the user experience, we aim to enhance customer satisfaction and encourage repeat purchases, drive sales revenue. For repeat customers, some orders can be pre-filled based on purchase history for convenience. And for the user experience, the website, we wish to evoke emotions such as credibility, trust, and providing a seamless and intuitive customer experience. And of course, efficient product discoverability. You can have the option to pay on arrival or prepay and get alerts on your phone. 50% of users are more likely to use a mobile app instead of downloading an application, hence the reason for a hybrid mobile app.